All right, we can get started. So, for the last couple of semesters, I've had the pleasure of watching Jenner break Racket in incredibly weird and obscure ways, and I'm excited to hear how he fixed them. So, off you go.
Thanks, Zach. Okay, hello everyone. I think it's better if I stand up, right? So, I chose a rather provocative title or abstract because when I was preparing this talk, I realized that we've been treating Racket real badly on the Pycket side of things. But before diving into this, let me just remind everyone of what Pycket is. Now, Pycket is this JIT compiler that we were working with Sam for some time that implements Racket. So the way that it works, it's built on top of this RPython framework. You write an interpreter in RPython, and just give that interpreter to RPython framework. It spits out a JIT compiler that implements your interpreter. So, as I was saying, we've been using the Racket binary. This is the current way of doing things on Pycket, using the Racket's expander as a front end. This Racket expander, given a Racket source, just expands the code, and we're taking that code, turning it into Pycket ASD, and just evaluating, right? So then some time ago, we decided to just had this idea of using the Racket bytecode compiler as a front end to Pycket, because we want to be able to benefit from the optimizations that are happening from the bytecode compiler, because they're specifically built for Racket code, right? So we use that bytecode compiler to generate the bytecodes instead of fully expanded program, S expression, and wrote a new expander that will take the bytecodes and then turn it into a Pycket ASD and just runs it, which turned out to be not as fruitful as we hoped it to be, mostly because of the inlining. I mean, it's not definitive, but the main problem we think was the inlining, because there's a lot of ad hoc optimization.
What kind of problem? What do you mean? Why was there a problem?
Because,
What do you mean by there was a problem?
Oh, I'm talking about performance problem, of course. It was a big performance hit for us, because when you inline a recursive program into the body of another recursive program, you get a big program. And hopefully, luckily, Racket's bytecode compiler is careful not to blow up the code size. But in the end, the whole point of having a JIT compiler is, of course, to be able to trace loops, right? To create loops and reuse those. You compile those traces into assembly and use those traces as much as possible. But if you have a big program, first, it's hard to detect that it's a loop. And second, as it gets bigger and bigger, the type conditions that is imposed on that traces to be reused are increasing as well. So it's getting less and less reused. The traces are less and less reused. So we're bailing out the interpreter a lot of times. So these kinds of problems led us to, we were just about to abandon that effort. At that time, Racket decided to move into share runtime, right? So this was mainly because Racket, mainly because, well, some presumptuous people like to program in Racket more than programming in C. So because the current runtime of Racket is heavily depends on C code. The the front end, the compiler, expander, everything is written in C, which has a couple of problems. First of all, you cannot easily improve that code. It is not easy for people to contribute to, and you can run the compiler or expander separately, just type reco make or reco expand, but you cannot easily improve them separately because the code just, you can just look at the compile.c and see for yourselves. The code, the compiler and expander are fused together. I mean, it's just a little mess. So, and of course, if you write Racket in Racket, you can support multiple virtual machines, multiple backends, so you can easily support a lot of runtimes, because the runtimes don't have to, in that case, if you have the whole Racket in Racket, then the runtime, the virtual machine doesn't need to write a lot of C primitives, or doesn't need to do much, right? So that was the idea, to dumping the current generic runtime and getting into share runtime. So the way that Racket does this is, I mean, the Shay is already a scheme compiler, right? It has the fundamental framework to run, and from the Racket's point of view, it is relatively easy to compile into Shay. But Racket has a new idea which is called linklets. Now, the linklets, we're going to talk about the linklets in a minute in a little more detail, but linklets is a new primitive unit of compilation. All the expander, module system, top-level evaluation, all of the implementations of those stuff are built on top of the linklets, right? And Racket is the way to move into a new runtime or supporting a new runtime. Racket is going to export things in linklets, right? So that's why new runtime, Shay, needs to be able to understand linklets, right? So, and expose the functions such as these, like compile linklet, instantiate linklet, make linklet, the linklet primitives, right? So it builds a little module to be able to understand the whatever Racket's exporting, and then Racket exports these 4 primary bootstrapping, so-called linklets. And Shay takes these linklets, load them into its runtime, and just everything's fine. Now, let's look at the linklets. As I said, linklets is a primary primitive unit of compilation. It has this grammar. What you would see in a linklet is import variables, export variables, and some definitions. It's just simple. And because that it's below the macro system and all the module system, it's not going to contain syntax objects, for instance. It contains something called correlated, which is basically a syntax object without lexical information. It's just a wrapper around the value. So the way to run a linklet is to instantiate it, and that means providing when it's instantiated, when a linklet is instantiated, it will get a couple of other linklet instances as imports, right? And starts to evaluate its definitions. And then we'll be ready to export a specific set of identifiers to yet another linklet. And all the modules, for instance, a module would presumably we will have more than one linklet implementing it, especially if it has a submodules. It will be in the form of linklet bundle, or sometimes the bundles have collections as well, which is called linklet directory. So everything is on top of this linklet. So what does this actually look like? Now, you're looking at right now one of those bootstrapping linklets, this expander. It's just a small portion of it because this linklet actually contains 3,000, more than 3,000 definitions. In the S expression form, it has more than 70,000 lines of code. But as you can see, it exports some important functions like read, eval, or expand. Oh, sorry about this. And these are renaming imports. So this is the internal name, and this is the external name. So other linklets are going to import read from this instance, and this linklet is going to be instantiated. When it's instantiated, it will evaluate this function. Actually, we have one slash eval here, and it's going to export it as eval. Now we have the exports. We have the one important thing. It doesn't have any imports. That's kind of makes sense because these are the bootstrapping linklets. These should be standalone things, right? And now what Pycket does is to create its own linklet on the stenomatic and just takes these expander and do basically the same thing whatever the Shay is doing, right? So what this means is, remember the old way of doing things? Taking the source code, the Racket source, running into some sort of expander, turn it into a Pycket ASD, and just run it on the JIT. Now, all Pycket needs to do is to take those expanders, turn it into JSON ASDs, because we already have a bytecode expander from the previous endeavor. So we can take those bytecodes and turn them into ASDs offline, and then load them in at the boot. So what happens is just. Why did I put this slide? Okay. This is what you see is the little portion of the definition of expand, and Pycket already has this definition offline in the form of JSON file. Right? So all it's doing is all it needs to do is to take these definitions, and load it into the runtime, which means putting this into its own namespace. Right? Then it means those functions, these functions that we are getting from these JSONs, are all going to be available in our runtime to be called in Pycket. That means, for instance, we can just take this boot function, which sets parameters like current loader, current compiler, current resolver, to these things, and these are also defined in the expander, luckily. We can run the boot, and then we can namespace require the kernel. Namespace require is also exported in the expander, and then boom, we can run read, expand, eval on that. Let me just run it, actually.
Is this all in Pycket land? So we're not talking about Shay anymore, right?
No.
Shay works. It's fine.
Shay works. Shay is another runtime. Right? Shay is just a backend, right? Mm-hmm. Now we're doing basically the same thing with Shay on Pycket.
And that's work in progress? Is that?
This is surely work in progress. Okay. So yeah, I can just run this. And now, as you can see, we took the string Pycket23, and no Racket binary is used in the preparation of this value. Right? It exactly loaded. Pycket just took the took those JSONs, load them into its runtime at the boot, and then all these read, eval, expand functions are available in our namespace, right? So it just actually called Racket functions. And we can also do things like dynamic requiring and read a REPL from the Racket base, which is an exciting thing. I tried really hard to prepare this, but this is unfortunately not working right now. It's probably going to work on Monday. it's just Murphy. So yeah, we could also do this. So that's couple of things. Now, when we get right now, we're getting the expander. We're not actually getting the loading the thread linklet, IO linklet, or regex linklet. But those implement real nice functions. Like for instance, today I've looked into this IO linklet, and I've seen a function that I implemented last week, which is called peak bytes. So because it implements input ports and output ports as well, those stuff as well. So we really, any runtime that you can put on put the Racket on, for instance, it's called JavaScript. Any runtime is not going to have a lot of things to do to support Racket, as long as it can read and understand the things that Racket is exporting. Of course, to be able to run things like Dr. Racket or Slideshow, you're going to need to be able to have an FFI to call Racket read IO, right? So you'll always going to depend on some sort of C backend, but getting these IO thread expander not only will allow us, actually allows right now I can delete a lot of code, a lot of our Python code from the Pycket code base. It will not only allow us to just have less codes to worry about on the RPython side, which is a really not nice language to deal with. But also, it will allow us to compare performances on a fair level, which we will be able to run exactly the same things with whatever Racket is running. And in the same way as well, this booting thing is exactly what Racket's doing. Whenever Racket sets the mood, it does this. It just sets the parameters and require the correct namespaces and all this stuff. And there's a couple more stuff that I'm not showing here that we're doing with the Pycket's boot, but it's all calling functions that we're getting from the expander, which is really nice. Right? I'm getting a free REPL. Right? We don't have to write a single line of code, and that is also exactly the same REPL that Racket is
running. I think I missed the part where, like, what exactly are you working on? Like, I saw the landscape, and it looked like from all the boxes looked like they were done, but maybe you could point out what you're working on.
Now, in order to be able to run these linklets, a runtime has to provide some primitives. Like for instance, because we're not getting the IO linklet, for instance, I have to implement open input file, peak bytes, those functions on the Pycket side, right? And also, because that the expander itself is using linklets to do its job, right? whenever it gets, for instance, whenever it gets this expression, it will turn it into a linklet. It will put this expression inside a linklet and instantiate it with different kinds of linklet instances. So, first of all, right now, what I'm working on is to be able to support every kind of linklet that this expander can generate, which means right now this expander can generate. The expander has a lot of code and a lot of forms inside. Luckily, I only need to worry about the core forms, which are like the let values, case lambda, define values, which aren't that much. But right now, I'm currently, for instance, writing the handler for let rec values. For me to be able to take it as expression, which has a let rec values, and turn it into an ASD inside a linklet. Right? So I'm basically improving these functions because a linklet is created with this compile linklet function. From an S expression, it compiles a linklet, and instantiation is done with this function. And these are all the things that I need to implement on the RPython side to build this. And of course, they need to be extensively defined or correctly defined in order to be able to handle everything that these linklets could do. So luckily, after this, we're going to be able to compare. For instance, one idea that we have is to compare the expander's performance on Shea and Pycket, which is going to be interesting. But if you have any other ideas.
So you're only doing the expander. You don't have IO
right now. Yes.
So basically, you're trying to write that understandomatic block
exactly.
so that it can take the expander linklet, compile it properly, so that then you can use it on any arbitrary system.
Right.
And this is all going to happen at this linklet level. So Racket is producing some already expanded code, or it's that the process between Racket to get to the linklets to then get to the understanding. What is Racket doing on its side first? Is it doing some expansion and then you get these linklets that then
no. Now the all these bootstrap linklets, which are really exactly for these expander, thread, IO, and regex, all of them are generated offline.
Right. So
and
those are offline. That's like a meta runtime almost.
Okay.
Right. that everything's been used. I get that. But what the bootstrapping thing? Right. So the Racket, you've got Racket. Are you saying that there's no Racket runtime, or just Racket code that then gets fed into these linklets? I'm kind of confused about what's happening. So I've got some arbitrary piece of scheme code as Racket code.
Okay.
How does it get to Pycket? What happens?
Right. What happens is we'll take that code. For instance, we can talk about this as well.
Okay.
This is a piece of code, right? And that is a piece of Racket code. And that will be turned into a Pycket ASD, right?
So the first thing it will be done.
Now, first thing it will be done is it's going to be fed into the open input string of the open input string function that we're getting from the expander.
So the string you get. will be first
Maybe
turned.
we should try to have a higher level. I think
Okay.
talking about the lowest level functions is not going to
Sure.
clarify Aaron's question.
I'm just trying to think of what the whole pipeline is like.
The pipeline previously included Racket. Previously, we had this pipeline. When we get a Racket source,
Yeah.
Racket's macro expander or bytecode
Well,
compiler.
your question is about the new pipeline.
Yes.
The new pipeline, when you get a piece of code in, how does it eventually get its way to Pycket?
Right. That's what I'm telling. Previously, we had this Racket binary has to work in the pipeline.
So
Right
don't
now-
talk about stuff that isn't what we're doing to explain what we are doing.
Okay. Right now, we're using Racket only offline to generate these Pycket ASTs from already provided linklets.
Okay,
Yeah,
pause.
okay.
So
Am I explaining this really badly?
you're
I do
talking,
that.
You're talking about the things that matter to you
Okay.
and not the things that matter to your audience.
Okay.
So like, I can describe how I would think about this, and then you can explain how Pycket does this. So the normal way I think of a scheme for going is gets parsed. After it gets parsed, it gets macro expanded. After it gets macro expanded, it gets compiled, and then that compilation gets executed on the runtime. So there are these like 4 distinct phases. So then what are those equivalent phases in the Pycket system?
Those are
Exactly
the
the
same
same, yes.
phases.
Okay.
So it's just that the parser and the expander are implemented in the language itself, like in
Right,
many
right,
scheme systems.
Right.
And the
So-
when the compiler is being built, we compile and expand the parser and expander, and because you have to do that ahead, you have to have done that already.
Right, because it's a JIT thing.
Even if it's not a JIT thing, in any system, you have to have already,
Yeah,
you can't,
your
you can't
whole-
use the
your whole
parser to
meta-
parse the parser
yeah, your whole
at
meta
the same
piece is
time.
already
Yeah.
ready.
You have to, just like any bootstrapping compiler, you have already compiled the parser and expander to some piece of code that's part of the binary of the compiler.
Right. So you've
And
got your
then-
compiler,
And then, so the compiler consists of,
and this is all Pycket JITted code.
so the compiler consists of some stuff that you wrote as part of the compiler
Yeah.
directly, and some stuff that you wrote, which includes the runtime system, the low machine code generator, but also the parser and the expander. And the pipeline is exactly the same. It's just that the parser and the expander are written in the language itself, like in
Yeah.
many
No,
scheme
that's not
systems.
a problem.
And they've been compiled into ASTs so that you don't have to run them on themselves
okay,
at
wait a
runtime.
second. You're also confusing me. You've got the Pycket thing is entirely self-contained, right?
Right now,
To
yes.
do the compilation.
Yes.
So when I feed code into Pycket, whatever this thing is,
What do you mean?
all right, your Pycket scheme system, your Pycket Racket system. The parser, so I don't see like parser, for instance, in the purple.
That's in the
So
expander.
the
That's
read
in
is
the
implemented inside the expander.
Okay, so the expander linklet there handles the parsing, the macro expansion phases.
Right.
And then all the results of that would then go into your, you would have an AST compatible with your Pycket JIT system, which would then start executing with your runtime vector.
Yeah.
Okay. So then we go directly from some string of code into one of the expander.
Yeah.
Okay. Good. All right.
Yeah.
I'm good now. I understand. So then all of this is happening completely outside of any of the Racket infrastructure at all. It's all been pre-done, all that other stuff, and then you're just running on your Pycket.
Yes. Right now, we're not running the Racket binary anywhere in the pipeline.
Okay, so I can take this whole thing and I can like sort of delete Racket entirely and just run
Yeah.
Correct.
at AST and it would do and it would be all.
Given that you have the linklet.
Right, assuming you already have your linklets, which are
Yeah.
your.
Yeah. As soon as you've already done your bootstrapping, you can just delete the previous system and run the new system.
Okay.
And the idea is that once everything works, which is not yet, the bootstrapping can happen on Pycket as well, and
Right, so you can then self
it can self but that takes a while to make that happen. Yeah.
That's a good one. Yeah. Okay. Have you maybe teased yourself with any benchmarks yet?
Benchmarks? No. I'm just trying to trying to be able to dynamically require the Racket base right now.
Okay. So
Whenever I'm doing it, it's.
why do you need the Racket base?
Just to, I mean,
the standard library.
Yeah.
Okay, so you need that for the runtime.
Right now, I want to be able to get the REPL from Racket.
No, it's not the runtime. It's just the standard library. When you write a Racket program, it loads a bunch of standard library code, like the Haskell prelude.
All right, so yeah. I was grouping that into not your low level runtime. I was meaning all the stuff that you need to be able to access when you're actually.
I mean, it's just another library.
Right.
Yeah, if you can't run the standard library, then you're not going to have a very fun time.
Okay, wait, maybe I don't understand. The dynamic required here isn't, I thought, the way you described it, I thought you were accessing the already implemented, already handled stuff, even existing Racket installation. Or are you saying you're...
This dynamic required function itself is defined within the expander.
Yeah, so that I get, but you're not actually reaching into an already expanded compiled ready. Oh, okay, so you're actually trying to pull in, like, say, from source and recompile the entire standard library for use. Oh, okay, so that was, I thought you were saying the exact opposite. I thought you were saying you were trying to use dynamic required to pull in from an existing Racket installation, and so that every time a Pycket function used one of the libraries, it would jump into a separate runtime from a separate instance and run that. But you're, okay. All right, might want to make sure that...
Feel free to ask questions.
Okay.
Right?
So then all you're saying here is
this is really cool, right?
We're just trying to be able to Pycket compile Racket base.
You say it again, sorry.
You're essentially just trying to say, can we Pycket compile Racket base?
Yes.
Okay.
Yeah. Can we run Racket base in Pycket?
Yeah. Without needing a separate
Andrew,
timer.
Can you hang on 1 second? You have to go. Bus is coming. Okay. I'll email you. Great.
Well, if you don't have any other questions,
Well, I can thank Janelle.